I want to talk a little bit about vNICs. We talked about creation of virtual network interface cards on our Menlo and on our Palo cards, right? Remember, with all the VM tags that we add to those packets. But now, how can we create those? I'm not going to create an actual vNIC right now because tomorrow we're going to talk about these server templates. And so I just want to configure a little bit about the templates that I can do here. So I can create some sort of settings that I can reapply to all kinds of vNICs. And tomorrow when we start applying that to servers, I can show you more about it. So I can show you more about how to apply those templates to certain servers. But now I want to focus already on the configuration that I can do on a vNIC. So there's an option called vNIC templates. Here I can enable if this is going to be an adapter fax vNIC or a VM fax vNIC. In this case, it's always going to be an adapter fax. Usually on the UCS system, I'm always going to configure adapter fax. I'm not going to configure VM fax. And like I said, I'm not configuring an actual network interface card. I'm just configuring a set of settings that I can reapply to that vNIC. Tomorrow we're going to talk about all kinds of things that we can do with templates and how do we apply them. So today I just want to show you what settings do I have for my specific vNIC. So this template, I'm giving this a name, so vNIC test. I select if this vNIC is going to be allowed on either Fabric A or Fabric B. And then there's a fun part that I can check, and that's failover. Now what is failover? Let's go back to our vNIC drawing that we came up earlier. This one. We have all these vNICs. What I drew here is just for a single Fabric interconnect. So a single I/O module in a single Fabric interconnect. If we have this twice, what we can do is, because we decoupled the physical layer from the PCI bus layer, so we have the physical ports on top of here and we have the PCI bus down here. Because we decoupled those from each other and we just use some encapsulation method, we can do a thing called failover. What that means is that, let me draw that very quickly. So I have my Palo card here. That Palo card has an uplink to an I/O module. It has an uplink to Fabric interconnect. Like that. And it advertised some vNICs on its PCI bus and two VHBAs. They all relate to a certain uplink. So this guy is using Fabric A, this one is using Fabric B, and that's how they are statically configured. Because as you can see in my template settings, I really statically select Fabric A or Fabric B. And that's how I'm going to assign them. That's how I'm going to assign VN tags to it. But maybe, ESX is very good in failing over its links, right? But how well does Windows, for example, handle failover of network cards? Basically, it doesn't handle it. So, to overcome that limitation of some certain some certain operating systems, like a Linux host where I just configure an IP address, but I can configure port channeling there. Let's say I'm running Windows Server, not running ESX, but just bare metal Windows, I might only want to present just a single network card to that operating system in the PCI bus. But I still want to offer network redundancy here. What I can use here is what's called the failover feature. What it does is it will start building a path on the primary fabric that I select. So I still make the decision Fabric A, Fabric B, but I click the checkbox, failover. So it will start up, it will set up its path, its VN tagged path up to the Fabric interconnect across Fabric A. Now as soon as an uplink fails, as soon as the uplinks fail on FIA, it will immediately start a failover towards fabric B. How will it do that? The system will pre-provision this path. So you will see a vEthernet here, so that's the primary one that's going to be up. And there's going to be a vEthernet here as well, but that's going to stay down. And it's going to stay down until there is a failover happening there. So if you check vEthernet and vNIC allocations, you will see if you select that failover checkbox, you will see two virtual Ethernet interfaces, one built via fabric A and the other built via fabric B. The one that I did not select in the radio button checkses, the one that I did not select is going to stay down. And the Windows machine is going to use fabric A, the path through fabric A, for its traffic. Then as soon as an uplink fails, it will start failing over. So that's my failover checkbox. If I'm configuring a Menlo card, that Menlo card does not have the ability to decouple the PCI bus from the physical port. Like here, I advertise a NIC towards down there, but to my network, this is something different. I will encapsulate that into a new packet and then send it across a physical wire. So that's a virtual thing. On the Menlo card, it's just a physical network card, just sending Ethernet packets on top of a link. So when I select fabric A, it will select fabric A. It cannot fail over to the other because I do not have that segmentation. This is only possible on the Palo. So when you're configuring your templates, and you are configuring a template that also needs to be applied to a Menlo server, might be a valid question in a lab. Configure a template for these couple servers, and one of those servers has a Menlo adapter in it. So you really need to be aware what the hardware in your servers is when you're stepping into the lab. So create a overview of the hardware. We'll talk about that tomorrow. So in this case, I'm going to disable the failover because I'm not interested in it. I'm just interested in advertising because towards the operating system, I will advertise only one NIC, right? So I have 2 times 10 gig available, but I will only use one because I only advertise one path. So in the case that I'm running ESX, usually I will advertise 2 vNICs to it. All right, so enabling failover or not. I'm not going to cover the initial and updating template right now. It's something for tomorrow. And now what remains is checking boxes. Which VLANs do I want to allow on this specific vNIC? So this is my VLAN allowed list on this specific network card. And so I check a few boxes, and here you need to be very careful with selecting these boxes because when I'm configuring the VLANs here, if I have those disjoint layer 2 networks, which I have, that means that, like I said, there's going to be a vNIC to uplink mapping. So going back to our mappings here, to our pinning configuration here, it's not going to be a server interface to uplink mapping, so client to server mapping or client to uplink mapping. It's going to be a vNIC to uplink mapping. So it's not going to be physical ports, it's going to be vNICs that I can pin because this is an interface, right? This is a client interface. And because I have that separated client interfaces, therefore I can choose another uplink for each one of them. So the virtual Ethernet interface will be pinned to a certain uplink port. And that's how I'm going to use that. So going back, if I select a production and a DMZ VLAN here, but going back to our drawing, what if I select a production and a DMZ VLAN on any given virtual Ethernet interface? So we have that vEthernet interface. It has allowed production and DMZ. Where does it have to pin to? Where can it pin its traffic to? Nowhere, right? we have to pin it to one uplink, but we cannot, because interface Ethernet 11 does not allow those two VLANs, and this guy does not allow those two VLANs, so I'm stuck here. So if I am using disjoint layer 2, I need separated vNICs for production VLANs, and I need a separate vNIC for my DMZ VLANs, because I need to have that one-to-one mapping from vEthernet or client interface to uplink interface. So be very careful when selecting this. Read carefully. So I'm just going to click a few VLANs. I can select from which VLAN, from untagged traffic that I receive from the server on this specific vNIC. If I accept untagged traffic, to which VLAN do I need to map it? So the native VLAN configuration. This is where the next step, so a comment, the virtual Ethernet will be down, yes. If the pinning fails, the virtual Ethernet will stay down. Same as for physical interfaces. If the pinning fails, I cannot bring the interface up. Alright, so the second place where I configure my MTU size is here in the vNIC template. Inside that vNIC template, I select which MTU that I want to advertise. Now the fun part here is that this is not a fixed value. Or what I mean with it, it's not a hardened value. That this value is going to be the advertised MTU size that I tell the operating system that I'm capable of. Technically, especially VMware is not very aware of these MTU sizes. So if I leave this to MTU 1500, which it is right now, if I just leave that there and I manually configure MTU 9000 in VMware, I will be able to send 9000 byte packets. So this is just an administrative value in the advertisement of the NIC towards the OS. But of course, if the lab tells you to configure jumbo frames, you will need to change the MTU size here, because they will not check the operating system. They will check it here in your configuration. Now, because most operating systems do not support anything bigger than 9000 bytes, the maximum size that you can configure here is 9000. If I configure 9216, it will error. So I will get a red text field that I cannot configure that value here. I need to configure 9000 bytes here. And that accounts for all QoS classes. So this is not per QoS class, this is for everything. But as I said, that's an administrative one. That global configuration is really the hardened and policed one. If I do not change the MTU size in my QoS class, in my system class, nothing's going to work. Alright, next setting is I need to assign a MAC address to the virtual NIC. Because of course it's a virtual NIC, so it does not have a burned-in address. So I will need to assign that MAC address to it. QoS policy. What can I do in a QoS policy? I can tell a certain vNIC to which QoS class it belongs. So for any given type of vNIC, I can select a certain QoS class. So all traffic received on that specific vNIC will end up in this QoS class. Usually that's not what I want. Usually I want to have control over the traffic that I send in the QoS class. So what I do then is I might trust the mappings that a host makes on its links, and then allow those 802.1p bits to be mapped to certain queues. That is where I use the host control radio button. If I set the host control to full, it means I'm going to trust the 802.1p bits that this host is setting. So probably I'm running a Nexus 1000V inside my blade, and that Nexus 1000V, I'm going to trust the mappings that guy is doing. So therefore I need to set this host control to full. And here in this QoS policy is also where I can configure traffic shaping. So here I specify a value in kilobits per second, how much traffic this specific vNIC can send to me. And this is actually hardware controlled. Am I saying that correctly? Now this is a software version, so this is inside the Palo card. All right, so again, if I want to do traffic shaping, if I get the question, traffic shape a certain vNIC, here I specify the kilobits per second value that I want to have in there. And I specify if I want to trust the 802.1p bits that I get from the server. Next policy that's important is my network control policy. By default, CDP traffic will be disabled going towards blades. That's a good thing because I do not expose anything about myself towards the network. But in case of VMware, which is pretty much what most people will run on their blades, VMware runs CDP. So if you see your physical NICs, which are actually, of course, those vNICs, those virtual Ethernet interfaces, those links will be visible in CDP if I enable that here in a network control policy. So when I enable CDP going towards the blade, I will see which virtual Ethernet interface that link is mapped to. So that makes it very easy for me to troubleshoot it. So I usually like to enable CDP when I'm running it towards my ESX servers. And I can change what the system will do in case of an uplink failure. Meaning if all the uplinks fail on a Fabric interconnect, what do? Do I do like say link signaling propagation? So when the link fails on the uplink, I bring down the links inside my operating system. So that is mapped all the way back. Let's say here on that virtual interface here, if the uplinks fail here, this interface will go down as well. That is the default action. So very useful. So VMware knows very fast that a physical uplink has failed and that the server needs to fail over. And that is the main, there's also a big advantage over other server systems. Those server systems have internal switches, so internal ports, and they cannot do that propagation of the fault messaging. So that's very enthusiastic about the failover capabilities of the UCS. So very useful. But I can change that behavior and change that to a very old system and saying for like, all right, so I just want to warn the system that my uplink has failed. Now there's a very good message saying here that if I change that if my failover checkbox is set, I will not be able to fail over anymore when I change this setting. I need to bring the primary path down. So the primary path that I have towards my Fabric, I need to bring that down physically in the virtual Ethernet interface before I can do my failover to the other Fabric. Very important checkbox. And then finally, what we configure besides the network control policy is, let's say, the pin group. And the pin group is, as I said, a mapping between a vNIC and an uplink. So that dynamic mapping that's happening, I can change that. So no disjoint layer 2 stuff here, only a vNIC uplink mapping that's going to be static. So if I configure a pin group here, that's done under the LAN cloud, I configure LAN pin groups here. And here I can tell, by the way, if you're using a Mac, you cannot configure pin groups. That's a Java failure. This drop-down box is not visible on the Macs, only on Windows. So I'm using a Mac, but I'm running the UCS manager always in Windows because I do not trust the Java implementation anymore. So I can create a pin group here and say for like, all right, if traffic is received on Fabric A, I will always select uplink interface 111. This has no relationship towards VLANs or disjoint layer 2 interfaces. So I could have two DMZ interfaces. One I always want to have on one uplink and one I want to have on the other uplink. So just static configuration. I can select a different interface to be pinned for Fabric A and Fabric B. So Fabric B, I will use port channel 102. And now I can do that static pinning, and it will warn you again, ensure that the selected uplinks are in the same layer 2 domain. Because otherwise, of course, the pinning will fail. If the pinning fails, I will fall back to another available uplink that does allow all the VLANs and stuff.